This is review for you on real numbers and properties. So let's talk about real numbers. What is a real number? By definition, a real number is a number that can be located on the number line. So it's any number that has a place on the number line. The number line is that line that has numbers and goes on forever. Remember. So real numbers can be divided into two categories: rational numbers and irrational numbers. So we have rational here and we have irrational here. It's kind of hard to see. Use a different color. So irrational here and rational here. And rational numbers are any number that can be written as a fraction. So 5 can be written as a fraction, so it's rational. 6 is rational. Irrational is the opposite. It can't be written as a fraction. So let's divide rational first. So rational can be divided into 3 parts. So rational can be divided into whole numbers, natural numbers, and integers. Whole numbers, natural numbers, and integers. Whole numbers are numbers that, whole numbers start from 0 and they go 1, 2, 3, 4, and so on and so forth, etc. Natural numbers are just called counting numbers. They're called counting numbers because they're whole numbers, but they start from 1 because usually when you count stuff, you start from 1, not 0. So natural numbers go 1, 2, 3, 4, and so on and so forth. Integers, by definition, are the whole numbers and their opposites. So that just means that it's 0, 1, 2, 3, 4, and so on and so forth, and they're opposite. So the opposite of 1 is negative 1, and the opposite of 2 is negative 2, and 3 is negative 3, and 4 is negative 4, and it keeps going. So integers they start from infinity, and they go negative 3, negative 2, negative 1, 0, 1, 2, 3, and it keeps going. So that's what integers are. So we can divide integers into 2 more categories: prime and composite. So we have prime numbers and composite numbers. And prime numbers, let me write over here. Prime numbers are any integer greater than 1 whose factors are only 1 and itself. So for example, 2 would be a prime number because the only factors of 2, the only numbers that we can multiply to get 2, are 2 and 1. And that fits the definition of prime, so it is a prime number. Also 7 is a prime number because the only factors are 7 and 1. That's what a prime number is. All the rest of the numbers greater than 1 are composite. Composite numbers are any integer greater than 1 which has more than 2 factors. So let's take 6 for example. The factors of 6 are 1, 2, 3, and 6. Because we can multiply 1 and 6 to get 6. We can multiply 2 and 3 to get 6. So it is a factor. Also, 4 is a composite number because it has 1, 2, and 4 as its factors. 2 times 2 is 4 and 1 times 4 is 4. So those are the factors of 4. It has 3 factors. This one has 4 factors. Both are greater than 2 factors here. So those are prime numbers and composite numbers. Now let's get into irrational numbers. So irrational numbers, examples of them would be non-repeating and non-terminating decimals. So for example, pi would fit that definition very well, because pi is equal to 3.141592 and keeps going. It never repeats, it never shows a pattern, it just keeps going on forever and ever and ever. And that would fit an example of irrational numbers, because pi cannot be turned into a fraction. There's only approximations like 22/7, but you can never get a fraction that's exactly equal to pi. That's impossible. So this is an irrational number. Also, the square root of 3. The square root of 3 is also equal to something that goes on forever and ever and ever and never ends. So what if you have a repeating decimal? For example, 0.3. It goes on forever, 0.3333333, and just keeps on going. Is that a rational or irrational number? Well, the correct answer is it's a rational number, because 0.3 repeating can be turned into a fraction, and that fraction is 1/3. So it is a rational number. Only non-repeating decimals and non-terminating decimals can be irrational numbers. Terminating decimals and repeating decimals are all rational numbers. So let me clear some space and we'll get into number properties. So the first property we're going to talk about is the commutative property. And the commutative property says that the commutative property says that the order in which you add or multiply numbers does not matter. You will still get the same answer. So let's try addition. A plus B is the same thing as B plus A, because if you substitute for numbers like 5 plus 7, 5 plus 7 is the same thing as 7 plus 5. It does not matter if you change the order. Whatever order you add those numbers, they'll be the same. And it also applies for multiplication. AB is equal to BA, because 5 times 7 is the same thing as 7 times 5. They're both 35. They're both the same answer. It doesn't matter which order you multiply things. It's the same answer. So that's commutative property. The next property is associative property. And the associative property says that the order in which you put the two numbers which you put parentheses for a 3-numbered expression does not matter which two numbers you put it on, because the answer will still be the same. So if you want an expression, expression A plus B plus C is the same thing as the quantity A plus B plus C. So let's do 5 plus 6 plus 7. And that's the same thing as 5 plus 6 plus 7. Because 6 plus 7 is 13. 5 plus 13. Whereas this one is 11 plus 7. 18. And this one is 18. Same thing. So that's addition. Let's try multiplication. A, B times C, the same thing as A times B times C. So 5, 6 times 7 is equal to 5 times 6 times 7. So 6 times 7 is 42, 5 times 42, well, that's huge, is the same thing as 30 times 7. Well, 3 times 7 is 21, so that's 210. 10 times 42 is 420, divided by 2 is 210. So that's correct. It's the same thing. So the associative property works. The next property we're going to be talking about is the identity property. Let me get a different color. Identity. And the identity property says that when you add a number with the additive identity, you will get that number. So A plus 0, which is the additive identity, you will get A, because anything plus 0 is equal to A. The multiplicative identity, or 1, if you multiply A times 1, you will get A. So 1 is the identity for multiplication, and 0 is the identity for addition. So that's identity property. So the next property we will be talking about is the inverse property. So inverse. So if you add or multiply a number by its inverse, you will always get 0. So A plus negative A is always equal to 0. And A times 1 over A is always equal to 0. Because 1 over A is the inverse of A in multiplication, and negative A is the inverse of A in addition. So you can try it examples, it'll work. I don't have enough time for that because we still have a few properties. Next we will be going over the distributive property. And the distributive property says that you can multiply a number and a sum by multiplying each term of the sum by the number and then adding these products. And this will work for subtraction as well. So distributive. So if you get A times B plus C, that's the same thing as AB plus AC. Also for subtraction, A times B minus C, you will get AB minus AC. And trust me, it will work. I don't have enough time for this, but you can test it out on your own. I'll leave it up here for a while and you can test it out. Pause the video and test it out. It will work. Now we will the final property we'll discuss is the closure property, and this is a hard one in my opinion. So the closure property says that the set of numbers is closed under addition if the sum of any two numbers in the set is also a number in the set. So let's say the set of whole numbers is closed under addition. Closed under addition. That means that any number, closed under addition, the set of whole numbers. Whole numbers. So you can add any two whole numbers and you will get a whole number. That is what the closure property says. You can add any whole number and you will get a whole number. So 2 plus 3 is equal to 5. 5 is a whole number, 3 is a whole number, 2 is a whole number. It will work for each and every one in addition. It will also work for multiplication. Addition and, I can't see that. And multiplication. It will work for addition and multiplication. So that is the closure property, and thank you for watching this presentation.